and the results that come out of OptiStruct are saved not on his C drive, but they're saved into the database so anybody from the company can look at it. Another engineer comes along, looks at these things and says, okay, I need to build the real part. So he looks at this and creates this model of the actual design part. Where does that get saved? Into the database. It's part of the product definition. Another engineer comes along and says, well, you know, we're going to still need to look at this and do finite element analysis. This was giving us a rough shape. This is going to tell us whether or not our real design is going to be able to support the loads and hold up the way it should. And so another engineer does this, and all of this information, along with a lot of other data, gets stored into the PLM database in a nice folder that has all of this information collected with it. So when I grab the entire folder on this particular product, I get all of its history, all of its information. I may even have a conceptual sketch. There could be a PDF form of a back of an envelope sketch that was done by an engineer saying this is roughly what it needs to look like. They lay it on a scanner, they scan it, and that scan, that PDF, drops into this same folder. Okay? So you get the idea. It's a collection of all of the engineering definition or product definition that goes into it.
I was going to say, we used D3D before. Is that kind of like a PLM?
It's very similar to it. Okay. So it's probably more like a PDM than a PLM. It's probably more just for managing kind of the engineering documents instead of everything else.
Oh, okay.
The next thing that you'll find in a PLM system is what is referred to as kind of the product production information. So inside of that, there may be a design of the factory. So this could be a factory CAD representation, okay, that's saved out in the PLM system. The next one could be an actual NC toolpath, a part program that is going to make this part. Okay? So this is the instructions that would be sent to a machine tool to actually make the part. This could be a set of instructions on how to inspect the part that was manufactured. This could be another set of instructions on how to actually look at it in its assembly conditions. So all of the production information is likewise poured into the same PLM system. Is it put in the part definition folder? No, it's put in the part production folder, okay, product production folder. And those are in a folder that contain all of the information for this given thing. It also, in the PLM system, it also has any kind of operating support information. So this could be information regarding sales. This could be working with our supply chain. So if we need to order material in to make the part, this could be a person that's doing the purchasing. Okay? This person here is kind of working with all of our distributors. This person here is working with the supply chain that's bringing in other related parts that connect up to this. And so the PLM system, okay, captures all of this data, product, production, and kind of the HR, the business element of it. It's all collected into a database, into a repository, so that you can easily go in there and kind of query it or take it and transform it into a new version, okay? Because it's all contained in one location. So drilling down a little bit, and if you have your books, you may want to kind of go and put an asterisk by this. But right in the book, he talks about the product definition. And in the product definition, he identifies these 4 elements that are part of the product definition. So in addition to what I just kind of stated, here's some verbiage that you can read to kind of clarify that previous figure. Likewise, you can go a few paragraphs later and find a discussion on the product production area, and he lists all of these things: material purchasing, facilities planning, maintenance, delivery. You can find all of these different aspects that are tucked in as part of the product production area. And likewise, in the operations support area, you can find a paragraph that goes in there and describes what is captured as data inside of that. So for this class, are we going to be worried about the product definition? Yeah, we're going to spend almost all of our time worrying about the product definition. Are we going to think a little bit about the product production? At the very end, when we start talking about rapid prototyping, or we start talking about engineering tolerances and things like that, we're really kind of beginning to think about that middle area. After today, are we going to spend any time on the third element, the support thing? Now, it's not a part of this class. It is a part of PLM systems, and you need to know that, and if you were to be asked a general question on a midterm or a final, saying, what's there? You don't want to talk just about product definition. While that may get you a bunch of the points, it won't get you all of them. Okay? Questions in the back?
Is there a course that talks about the operations support side of it?
There's not. We are toying with the idea of changing 574 into a PLM course, which would spend an entire semester talking about this environment.
What is 574?
Currently, it's a product definition class or something. We're talking about changing that to be a PLM course, and we're working with Boeing and with General Motors, seeing if we can get an entire data set. Boeing gave Georgia Tech the F-86 data set. It's a Korean War fighter jet. They gave them the entire data set of that airplane, and it's in a PLM system. And so you can go in there, you can do redesigns, you can do changes, and you can watch it ripple the change effect, go all the way through the kind of plane and modify it and update it. So we're thinking about adding that. Okay, your textbook also shows this little diagram, and I apologize that it's not real clear on the overhead, but it's intended to show you how a company without PLM is organized, and these dashed lines that show up, quite a few of them, are areas in which it's kind of an over-the-wall treatment. If you want to get something to your supplier and they don't have a PLM environment and you don't have a PLM environment, what you typically do are produce a set of drawings and what? Put them in a tube, ship them to them. Or in modern terms, you scan them, right? PDF them, and you send them to them as an attachment in a PDF. And they open them, and what do they do with them? Well, they start by recreating them, basically, okay? So this is what is heretofore been the operation of the world without modern PLM systems. This figure, also in your book, is intended to kind of represent the modern PLM environment. And you'll notice all the dashed lines have gone away, and they put in their place little acronyms, EM and ES and so on. And it's to represent a tie a link between what is on your computer PLM system and what you're willing to share. The way it works in today's world is if Boeing wanted a company in Korea to design part of the 787, they can either allow that supplier to enter their PLM system and see only the portion of the plane that they want that Korean company to bid on, and they can look at the models, they can go in and manipulate the models. The only thing they can't do is overwrite the models. So if they're in your PLM system looking at things and they tweak something and they go to say save, what's it going to allow them to do? Save a new version. They can't drop it on top of the Boeing release version. They can set up a new Korean version with a special, extension to it that says we've tweaked it, we've modified it. Okay? So this whole environment is what is known as the PLM kind of network cooperative environment, where you can interact all the way out to customers. If you want customers like United, Delta, if you want large airline companies to be able to come in and look at a new design and give you feedback on the interior, on the luggage space, on the cockpit, you would allow them to literally come into your environment, look at it. If they tweak things, that's fine. They just save it off as a new version. Your textbook, I think in an excellent way, identifies the benefits of PLM systems. You need to know these benefits. You need to understand them. When you go out and are hired to do an engineering job, your company will either A, be using and already know the benefits of the PLM system, or they're thinking about picking up a PLM system, but they're not sure about it, or they don't know the first thing about it. And so regardless of which one of those environments you fall into, knowing and understanding what it is and what the benefits are is going to be very important to your career. Okay? And so we could go through and kind of talk about each of these things, but what I would like you to do is read through this benefits section, and on Thursday we're going to take a few minutes and just have a general discussion about the benefits. Okay? So instead of kind of hitting you cold, if you haven't read this yet, read it, okay? And we will then talk about it on Thursday. Okay? Hopefully you'll do more of the talking than I'll do. I want to kind of hear your thoughts and your impressions, your reaction to what the author indicates the benefits of this thing are all about. So what are the actual tools? What are the PLM tools? Well, the one that has captured the largest share of the PLM space is called Team-Centered Engineering. And a couple of years ago, it was believed that they had about 70% of the market tied up. My guess is it's gone even higher. Okay? When the other tools have kind of benchmarked against the team-centered engineering environment, they really had a kind of a difficult time in meeting kind of toe-to-toe with them. So we are going to be using team-centered engineering. We will have a team-centered engineering client here at BYU that will link us to the mothership